Hey y'all. So I'm about to catch up on the SpaceX launch since I had missed that launch yesterday. Uh, well, early this morning. Want to catch up on that launch and take a look at it. Now, as most people probably know, SpaceX designs, manufactures, and launches advanced rockets and spacecraft. And early this morning, there was a launch of, I believe, 20-something different satellites that they put in 3 different orbits. So the launch happened pretty early. I didn't end up waking up to catch it. But we can take a look at it now. I believe the launch was from Florida.
You're looking at a live view of the Falcon Heavy on historic launch pad 39A at Kennedy Space Center, awaiting liftoff at 2:30 a.m. local time. Welcome to our live webcast of the Falcon Heavy Space Test Program.
The Falcon Heavy is pretty interesting.
Or STP-2 from SpaceX headquarters in Hawthorne, California.
So, Falcon Heavy, it cost $90 million to launch it. Standard payment plan. 2018 launch. $90 million. It can lift up to 140,660 pounds to low Earth orbit, 58,860 pounds to geosynchronous transfer orbit. And by the way, the $90 million was to geosynchronous transfer orbit, and payloads to Mars, 37,040 pounds. So shows they already have plans in place, or at least the vision in place to get to Mars.
Our 3 boosters will undergo 3 separation events and 3 landing attempts. There will be a lot of activity happening all at once over the course of the next 4 hours as we deploy all 24 payloads.
So that's 24 different payloads on this rocket. The launch is about to start momentarily. So we got 30 seconds to lift off.
T-minus 15 seconds.
Hey, what's going on in the Matrix? How you doing?
10, 9, 8, 7, 6, 5, 4, 3.
If you want to get on, the meet information is in the description.
Ignition.
Awesome. Taking off. Now, right now, there's a lot of live viewers there. And interesting as well,
just 25 seconds into flight under the
Right.
thrust of over 5 million pounds.
Now this thing is already at
Headed to space. We're getting ready to
700
throttle
kilometers
down
an hour.
for passing through the period of maximum dynamic pressure. We've heard call out of throttle bucket for sidecar.
If you want to talk about ETs or something, Matrix, I could spare some time. Hey, what's going on, Matrix?
Vehicle is supersonic.
Can you hear me?
Continuing to
How's the
look
mic?
good on
Mic
the
check?
Merlin
Yep,
1D.
I can hear you now.
We're throttling back up on the side boosters.
Want to talk about ETs or something? I can spare some time later. I'm gonna get you this launch first, though. I meant to wake up early and see it, but I couldn't wake up.
Performance looks
I was here at 10:30
It's
last
going on
night.
live now, Darryl?
No. This is from this morning. So what happened is they're sending up 24 different satellites for, I believe, the government. I'm not sure exactly who. The launch window was from 10:30 p.m. yesterday to like 2:30 a.m. today. And I was here at 10:30 last night, but maybe the weather or what have you, they had to push the launch back. And so it launched actually about 1:30 or 2:30 this morning. So this is just the replay. I'm just playing it from their video because I didn't get a chance to watch it yesterday. And I wanted to just look at the progression of the technology of space travel, even though it's still close to the Earth. But
it's
pretty cool.
To minimize acceleration and loads on the
now one thing I wanted to check out, I noticed that Reds Rhetoric, likely in response to Flat Earthers, he did a live recording of the launch.
Boosters to decrease that load.
How close are we allowed to be from the event?
I don't know. I don't know exactly. I've seen footage of where I've seen people. I don't know if that's the closest they can be, but from what I've seen in like promotional material from SpaceX, I would say about between 1 and 3 blocks away. Probably about 3 blocks away, something like that, 2 to 3 blocks away. But that's just a rough estimate, like 2 neighborhood blocks away. A rough estimate from what I've seen in promotional material. Like when they played that promotional material when they sent Starman up into the sky. That was about, I think I saw people as close as about 2 blocks away. Now this right here is Reds Rhetoric taking a video of it while he was there, and he just spliced it next to the actual video. What I'll try to do is find a spot where they. So right now they're separating. Looks like they're separating the smaller rockets. So he took a pretty cool video. So as you can see, those they are the 2 side rockets there. If I'm understanding properly. Let me widen this up some. Oh, and let me present. Are you watching it on YouTube, or do you want me to present inside the Hangout?
I'm watching it on YouTube, but you can present it if you like.
Wait, a moment here. So present. I'll present this left screen here, screen 2. Awesome. You might not be able to hear the sound, but I'm not really playing the sound from the video anyway. I'm like have it really low. But yes, so now you're able to see it right along with me. So yep, there was a side booster separating. So now it's just the main booster going up. And my understanding is, so this is the separation right here that he's catching. He's videotaping this with a P900. So it looks like we're about in the same spot right now. Say again?
Everything looking good on the Falcon Heavy.
So, yeah.
Which one is Reds Rhetoric's footage?
Reds Rhetoric is that one on the left with the red up in there. And SpaceX is this one on the right here. So Red X, and you can see the little aura right there on the right side. That's Red Rhetoric. It looked to be about in the same spot right now. So right now the two side rockers are coming back to land, while the center one is still pushing it up into the atmosphere. So it's pretty high. It's amazing how high we can see up. So right now this thing is 137 kilometers up. So I believe that would be what? I don't know, 200 miles, 225 miles. I don't remember which way it goes, whether it goes up or down for kilometers. I never really focused on kilometers too much. Of course, spin in America. But that's pretty much the end of Red's video. He was able to catch the separation.
Is it just this? Is this like what it doesn't show separate when it leaves Earth lower atmosphere?
You mean from liftoff on the ground, or you mean up high in the air?
Yeah, exactly. From liftoff all the way until it descends to.
Yeah, of course.
Space.
You just came in after the liftoff happened. I could have scrolled back really fast. So this is a liftoff right here. This is how it looks when it's on the pad. And I imagine all that smoke is the coolant coming from it, because I know they have to put a lot of coolant in there to keep things going, because obviously that's not steam because it's going down. So now it's about 40 seconds from liftoff. So I'll just push it forward a little bit. So this is the liftoff going on right here. And if you
that's
look,
the footage that they provided, Darryl?
Yeah, this is from SpaceX.
Oh, okay. Oh, it's SpaceX. All right.
So now it's about to take off right now. So look at this thing. Look how fast it goes. It's already at 40, 50, 60, 70, 80, 100, 130, 170. This is the speed, kilometers per hour. 250. So 20 seconds in, this thing is already at 400 kilometers an hour. It's a kilometer up into the air. See, and each of those rockets has three different, not three, but each of the three rockets has, I believe, 824. Each of them have several different rockets at the bottom, so it's like a combination. So it looks like it's just one rocket because the fire is all there, but you can kind of see if you look real close, there's a whole bunch of smaller rockets grouped up together, and they work in tandem with each other. So it's pretty cool. So this thing could actually get to Mars. This thing right here, it could actually get to Mars if they decided to send it to Mars. So one of these rockets, so it has three of them, the booster rockets. One of these booster rockets has 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 8 going around the outside, 8 going around the outside, and 1 in the center. Is what I'm seeing here. Let me go to the Falcon Heavy to be sure. So if I understand it properly, the Falcon Heavy just has 3 of the same rockets put together. Yep. So this thing here has 24 rockets all together between the 3. 24 smaller rockets, 8 inside each one. Or excuse me, 9 inside each one, so that's 27. 9 actually. So 27 smaller rockets all together, grouped together, causing all that thrust.
That's a lot of rockets.
Yeah. But it's carrying 24 different satellites though. I saw a video somebody put up detailing a few of the things they have going up, and one of them is like this futuristic sort of space vehicle they're working on, where it's like a solar cell. Like the only power it has is a solar cell. It reminds me of something I saw in Star Trek. Might be where they got the idea from. Another one is this very advanced clock. This very advanced clock that's in orbit. So they can, like, let's say the ISS or the astronauts can help better gauge their time, maybe the other satellites as well. So yeah, several things went up, 24 things in total in 3 different orbits. So right now it's going at 1,500 kilometers an hour. It's 15 kilometers up into the air. Let me pull up a kilometer to miles translator there. Right, so this thing it's going 2,100 kilometers an hour. That's 1,300 miles per hour. So I think I had it to reverse earlier. So it's going over 1,000 miles an hour right now, and it's 18 miles up in the air already. We're 1 minute and 45 seconds up. So at this point, the the booster rockets are still there. And one thing you can notice, this is one of the things that Reds Rhetoric pointed out when he was debating somebody. One thing you can notice is the fire that's coming from the rocket. Like if we go back to right after liftoff, the fire is really thin. See how the fire is really thin and contained right there? You see how that looks? But as it goes higher, because the atmosphere is thinner, the fire gets wider and wider. So if you look right there, the fire is a whole lot wider.
Wait a minute. But if there's no atmosphere, shouldn't the fire get less because there's less molecules in the air?
Well, good way of thinking, but it's the opposite. So in other words, down here the air pressure is higher, so there's more air pushing against the fire. So if you imagine, like my fingers. Let me pull up my camera so I can make sure you see. So my fingers.
That's interesting. I never thought about that. That in space it will actually be. Are you talking about the rocket leaving lower or entering lower Earth orbit?
That is correct, because on the ground the air pressure is higher, so there's more air pushing against the fire, so it's thinner. But as you go up, the pressure gets less and less and less because gravity is pulling all the air to the Earth. So the higher up you go, the farther away it is from the center of gravity, so there's less air. So now there's less stuff pushing against the fire, so the fire is wider. And if you look at the launch from ground to the sky, the fire gets wider and wider and wider. And when the last rocket gets all the way into low Earth orbit, it's like almost like a fan. It's not even going straight, it's going sideways at the sides. You know what I mean? Because there's very, very little air pushing against it. So the fire just expands, which is what it's always trying to do. So look at that part right there. You see what I'm saying? So you see how wide it is right there?
Yeah, that's the parts falling down.
Exactly. So these two right here, are you able to see my mouse in the video, by the way? In the presentation inside the Hangout?
What was that?
Are you able to see my mouse in the Hangout?
Yeah, I see your mouse.
So these two here are the two side rockets separating, because you notice how it was all three. So as you can see right here on the side windows, these are the two rockets separating, and this middle fire here is the main rocket still going. As you can see, it's higher in the atmosphere. There's less air pushing against it, so now the fire, you can see how wide it is. I'll back up just a little bit so you can see that again. So boom, now it's about to separate. I think I hit my. That is right there.
I find it a little weird why they don't ever put a camera facing up.
Well, I mean, I would imagine. I mean, can you think of a reason why you may not want to put a camera facing forward on the craft going through the atmosphere at a few thousand miles an hour?
I mean, not at all. You know, it will actually be a very interesting thing to do. You know what I'm saying? If you could secure that camera, I mean, there's all sort of safety glass or whatever. You know what I'm saying?
So, see, well, perhaps you should write to him, or maybe perhaps you should write to him and suggest that. Maybe they'll follow your suggestion.
Could be a good idea. Write them an email or something.
Yeah, go ahead and email SpaceX. All you got to do is go to SpaceX.com. Let them know. Maybe they'll put it on the next one. Now, right now, we're looking at the center one is the main rocket. Right now, it's at 127 kilometers in the air. Let's see how high that is. So that's 78 miles up. So now, if you look at that middle rocket now, well, it's kind of hard to see because it's kind of close. I always like how molten hot it gets, man. So I wonder what material that is. Maybe it's some kind of titanium or something. Now, if you look to the sides, those are the two little rockets starting to land. Okay? So it looks like that's the center one breaking apart right now because the rocket is made in stages. So there's the two on the side that breaks off. Then there's the center one. The bottom one is a booster rocket. And then the top one, my understanding is its own rocket as well. So right now it's going 12,000 kilometers an hour. 12,000 kilometers an hour. That's 7,450 miles per hour. It's almost 200 kilometers in the air. So it's going about 7,500 miles an hour.
You see that gold foil, that baggy material thing?
Right. I guess right here?
Yeah. You see how it's moving, right?
Let me see here.
Giving the impression of maybe there's nothing inside. It's just like aluminum foil, kind of.
Yeah, I can see that. I can see it. See it seeming like.
How is that?
Now those side
What
boosters
kind of
are
material
making
is
their
so
way back.
flexible,
Their grid fins
yet so
on all
resistant that
three
it could take
boosters
all
should
them
be
G-forces
deployed,
and not rip
and
to
those are
shreds?
self-guiding
Have you
nodes
tried
that
looking
are
into it to
landing
find out?
gears. As a reminder, today we
Not
are
at all,
honored
but it
to
would be
recover
very
all three
interesting
of
because
these
I've
super
actually
stages, and all three boosters
grabbed
are currently
aluminum
making their way home.
foil like on a
In
motorcycle
just a few
and
minutes,
going
the
pretty
side
fast,
boosters
and
will
this shit
Mhm.
enter
tears
into an
apart
entry
pretty.
burn followed by a
Mhm.
Imagine
landing burn. From
motorcycle
center
doesn't
core
go
to the
500
landing
miles an
gear.
hour. You know
Mhm.
what
You'll
I'm saying?
complete
This
the
is
same
going
burns just a few
a
minutes later.
few
Those
thousand
burns
miles
are
an
used
hour.
to slow the
So
stage's
I'm
speed
wondering
down
what kind of
rapidly.
material is so flexible yet so durable that it's just gonna stand yet alone the heat, the
Hey, what's going on,
pressure,
Gentleys?
and the velocity of you know what I'm saying, and still be flexible. It's a
Are you going to look into it to find out?
I mean, shit, if you could give me a link or something.
Oh, certainly. I can give you a link. One moment.
Drone ship is positioned twice as far offshore than normal, so we may not get visuals of landing tonight. Also coming up in a few minutes will be the call out for second engine.
So this right here is the SpaceX website. This is the Elon Musk company that sent this out. I'll put it in Hangout as well. So perhaps you can go there. You can look through the site. Maybe you could find where they link the materials is made from. If it's not fully there, perhaps you could write them and say, hey, what's that material that it looks like aluminum foil on a rocket? And pretty sure somebody will contact you. They seem pretty friendly in SpaceX. I notice when they do their presentations like here, like I have it kind of low right now, but they always communicate with people. So yeah, check out that site. You can email them or look through the site. They may have the materials break down right on the site. So now what we're looking at here, if you look at this left side here, that's the two rockets about to land. So those are the two side booster rockets they got coming down on their own. So that's one of the things that Elon Musk did. So he realized that it was kind of a waste to. Awesome, Gentleys. Glad to see you here. So I wasn't able to wake up to catch it this morning, so I figured I'd just come on and watch it now, do some commentary on it. Now, one of the things that Elon Musk did, he realized that it costs a lot of money to make these booster rockets, and NASA was just, you know, they would just fall in the ocean and they'd let them sink, or they'd tow them in and junk them, or whatever they would do, but they wouldn't reuse them. So he found out a way to design rockets to where the booster could be used over and over and over. So that's why you see these two ones coming down again on the side. When they broke apart, they're going to land back on the ground on their own. So now we have the main one that has the actual satellites is on the right. That's the one that's still in the atmosphere. It's going 22,000 kilometers an hour. So let's see how fast that is.
Side booster landing burn to begin on both boosters.
Side boosters transonic.
That's 13,000 miles an hour.
About 10 seconds away.
All right. So now we're about to show the landing. Now I remember watching the video for the first landing they did. How excited everybody was, because that was really the first time anybody made booster rockets land. Here they come about to land. Boom. You see that on the left side right there? That's awesome. So that's some good engineering right there. So these two about to land at the same time. There's one on the left, one on the right. So boom, the one on the left landed, the one on the right about to land. Boom. So 8 minutes in, both side booster rockets have landed. The center body piece is at 304 kilometers an hour. Excuse me, 304 kilometers in the air. That's 188 miles up. 188 miles up. Not hundreds of thousands of feet.
I'll tell you, that's some beautiful cinematic work they did.
Certainly is, man.
As we mentioned earlier,
So that's it's 999,000 feet up. So the highest weather balloon, remember I went about 90,000, 100,000 feet up. This thing is 999,000 feet up. So it's almost 10 times higher than the highest balloon we've seen. At least that I've seen. I think Rob Skiba's is the highest one I've seen. Hey, what's going on there, Cool? How you doing? If you want to join up, the join information is in the description. Anybody wants to join, anybody can join. So what I'm going to do here, let me hear what they're saying.
Complete, the center core is moving back about 20% faster than it was at the end of the Falcon Heavy 2 Arabsat entry burn.
First stage KPL is expected.
Awesome. So
We're
at this
coming up,
point,
we're just about a minute away from that center core landing burn beginning.
so the
And as we've been
center core is about to
mentioning,
land.
this
The
will
center
be
one.
the most difficult.
So one thing to keep in mind about rockets is, like, one of the things I heard Flat Earthers say before was, I don't know what website or whatever, but they was quoting some guy from years and years ago saying rockets are too big and they're too heavy and the fuel is too heavy. They'll never be able to get to space. It's too heavy. You ever heard that before, Matrix?
It sounds familiar.
So what they do is, so one, you saw they had 3 rockets together and 2 of them broke off. So they was able to use the full strength of all those rockets, and maybe not all 3 of them, if they stayed all together, would have enough power to get all that fuel up together, but they could all get up so high and then break the 2 off. So now the middle one is already a lot of the way up. So then the middle one go ahead and push up some, but so if you notice, the middle one is taller than the other 2. Did you notice that? Like, the 2 on the side is short, but the middle one is very tall. Did you notice that in the video?
Yeah.
So the middle one is actually 2 rockets. So the 2 ones break off, then the middle one is starting to go up by itself. Then the bottom half of the middle one break off. So now this thing is like already, you know what I'm saying, 200 kilometers in the sky, and now it only has 1 small rocket, and it only has a little bit more to go. So that's how they worked out being able to get that high, by making it into stages. So the heavier parts can be dropped off, and now that rocket is lighter, and they don't need as much fuel to get the core part where it needs to be. So what we're seeing on the right here, that's the top half of the middle rocket that actually has the satellites it's going to deliver. And all 3 of the stuff that really has all the main fuel and the main power, they could fall away and let the middle one just go on its way. So it's kind of like if we got to get to something really high, instead of you trying to jump all the way up there, I can put you on my shoulders and then you can reach it. You know what I mean? So it's just like that. So that's some pretty good engineering.
That we've had,
and I don't doubt that somebody might have said that in the past, like a real actual scientist, because everything at some point people said it was impossible. Like, people at one point said that going past the speed barrier was impossible, going faster than the speed of sound.
And we're just 30
I imagine that's why they call it a barrier. So, but we have several craft that go faster than the speed of sound now. So, yeah, a lot of things are seen as impossible until we work out a way.
First thing you should understand, bro, never listen to what people say. People don't know shit.
I hear you, man. I hear you. What did you hear about the nobody could get to the Antarctic from?
The treaty.
So you read the treaty?
No, I haven't read it.
What did you hear about what the treaty say from? So you watched some videos, so you heard what people say who don't know shit, right? Y'all funny, boy.
I take opinions, you know what I'm saying?
Exactly. Hold on now. So you just told me don't listen to nobody. When I'm looking at this video, I don't listen to people. People don't know shit. But you take and listen to somebody's video. So why can you listen to people but I can't? Explain that to me.
No, I didn't say you personally. I'm saying don't pay attention to what everybody says, because not everybody got important shit to say, which is people. Not all people don't have shit to say.
Now you go qualified. You hear that? You hear that, Loken and Akum and Gently? Now you got to qualify when I point out he is listening to people. And then you're listening to people you don't know nothing about. And then when I pointed out that there's a race around there, you just change the subject and say that's not going to be good enough anyway. So when somebody's telling you in a video that you can't get to Antarctica and you believe it, and then we show you evidence that people go and race around Antarctica.
What makes you think that I believe it just because the video says it?
Because you said it. You said nobody could get to Antarctica. That's what you said. I asked you where you learned about that from. You said from the treaty. I asked you where you learned about the treaty from. You said from the video. So either you start to be illogical, or you just got to admit that you believe the video. But it is up to you.
I haven't gone to Antarctica. How would I personally know that?
Exactly. That's my point.
And I told you that I didn't read the treaty. So
yeah, you told me that. But what did you say? But what did you say it was from? You said it was from a treaty when you never read it. So you don't know what the treaty says. So you're the one that's believing people.
I've looked it up. I just haven't really read it.
Exactly. So you don't know what it says. You believe that person's video when you told me that the treaty says it.
not just one person, a few. You're talking about at least 25, 30 different videos on a topic.
Hmm.
So when you're just saying one person, it's kind of, you know, not
Well, it doesn't matter
really.
how many people you listen to people. So I listen to the millions and millions of scientists over the last thousands
I
of
mean,
years.
it would be illogical for you to literally not listen to people, because who would you listen to?
Good. Well, we're in agreement then. It's awesome. So looking at this rocket here, I believe it just missed the middle, and the middle one actually failed to land properly, which is okay. I think that's why this launch was one of the most difficult ones, because they was trying to land all three. And as you can see right here, it actually went into the ocean and blew up. At least it looks like it blew up. Yeah, so that's sad. Let me see what they're saying in the chat. What's going on, Rez? Look, it says 50 million soldiers. I've heard something like that before too. Having a quick look, I think the thruster nozzles are made from Nibion alloy, but nothing specific. The fuel tanks are made from very specialized aluminum alloy. Alright? So Gentler is just saying that the thruster nozzles, the part you was talking about, is from Nibium alloy. Awesome. Very specially welded. Awesome. But it's certainly unfortunate he
And
couldn't
so
get
our
the
primary
get
mission
the get the middle part to land, but so now I'm gonna speed up a little bit because ain't much going on right now. So what's going on now is basically they try to get it to where it needs to be. So as you can see, it's steadily climbing in altitude.
That the Oculus satellite was
Ah, awesome.
and P-pod number 1
Thank you.
opened up,
I appreciate it. Appreciate it, Rez.
Naval Research Laboratory satellites. There's a view from space, and if
Awesome.
you remember the view just before we left.
Uh oh, what happened to my video?
On
Let me
the
just take a
left
minimize the video.
was the Oculus satellite, had a white coloring to it.
I'm gonna see that view again.
It appears.
Oh, I thought somebody else was about to join. Remember that the join information is in the description, so if anybody wants to join, the link is right there.
Deploying the Naval Research Laboratory.
Now this is the view from space right here. They're turning the cameras towards space.
Remember the view just before we left?
And this is a nice view towards the ground. Now right now this thing is 402 kilometers into the air. So that's 1,318,000 feet into the air. So it's 1,318,000 feet into the air. That's 13 times higher than the highest balloon that I've seen.
The Oculus satellite had a white coloring to it, and
so now we're getting an idea of how high space is. And this is still, my understanding, low Earth orbit.
That's going to take about 30 minutes to get through this sequence. You know that the in orbit, this sat that acts like a lens in a telescope.
The signal.
Ground station beyond Ascension Island.
That's pretty cool.
The signal
now if you look, you can kind of see the payloads here. One moment here. Because I've looked at one of these videos before. And it looks like these are parts of the payload that they're going to release. Like this right here, this golden thing right here. Looks like there's another payload back here, this white thing. So all of these seems like the payloads they're going to release. This looks like a little satellite right there. I can't be sure. But we'll see as we get farther into the video.
The signal from Falcon Heavy second stage.
So I want to see some of the parts where it releases some of the satellites. One good thing about watching it later is you can skim through some of the parts. One thing would be interesting too would be to take a video of this part. I don't even know how big a telescope you'd need to see this really well. Plus the sky would have to be pretty good. What do you think about this part here, Matrix?
Quite a mouthful. Primary goal is to use a dust
Still here?
detector to characterize
Yeah,
the
yeah,
space
fantastic
debris
work
environment,
of
focusing on
cinematography.
I agree.
sub-millimeter debris.
And right now it's
Be seen by
500
Earth-based
kilometers up into the
telescopes.
air.
Now, this
That's
satellite
310
is
miles
mounted
up.
on the opposite side of the dispenser.
It's pretty
So
neat.
again, we'll only have verbal call-out.
And you can kind of see how it looks like when they zoom into the Hammurabi photos. No, it's actually 20. What was it? 26, 20 something, 24. I believe it was 24. 24 satellites in 3 different orbits. Nice to see you, by the way, Anacito. So 3 different orbits, 24 different satellites, if I remember right. Either way it goes, more than 20. And I know it's 3 separate orbits. So they're definitely getting more advanced. They're definitely getting more adventurous, more, that's not even a proper word, more ambitious with their missions. So I think it's pretty cool. You know, Elon Musk is obviously a genius.
Until we get to the next deployment.
So now we're about to get to another deployment. Let me see, how long did he say?
Next deployment. Quick turnaround. Only about 145 seconds until we get to the next deployment.
So 145 seconds to the next deployment. We can go ahead and see a nice deployment. So look at that space debris right there. Might even be something coming off the satellite. I mean, off the rocket or some other rockets that was there. I would say it has to be coming off the rocket because how fast it's going. This thing is going at 25, almost 26,000 kilometers an hour. So this thing is going 16,000 miles an hour. So I haven't looked at rocketry in detail. But my understanding is right now pretty much is free fall, taking it along. So they got it up to enough speed that now as it falls towards the Earth, the curvature of the Earth makes it dodge the Earth. So then it keeps on falling, and the curvature of the Earth makes it dodge the Earth, and it keeps on falling. And they can use these thrusters to make it make sure it's in the right spot.
And BrickSat is a small satellite that has a micro-propulsion system
Okay.
to perform experiments with
ice. Good point, Gentleys. Because it did come out from the atmosphere, moisture on the rocket, especially with all the exhaust that's coming from it. But it has to be traveling as fast as a rocket, so it has to be coming off of it in some kind of way. So it's going to deploy several different satellites. One of them has some thrusters. I'm pretty sure that won't convince them, though. They'll say it's like a TV screen instead of a window or things like that.
P-Pod 4 deploy confirmed.
And we have confirmation over the net from avionics.
HPK.
P-Pod number 4 has deployed.
Awesome.
At the same time, we now have acquisition of signal.
So there was a deployment just now. Must be on the other side away from this camera. Let me see if I could get one in front of this camera here. I wouldn't mind putting a satellite in space. I looked into the cost. It costs a whole lot of money. Like if a lot of people put money together, probably be able to make that happen. I think it'd be cool to be able to.
Looking up around 2 o'clock at the top of the stack, trying to see if we can spot.
That's true. Didn't think about that. Talking about Reds F-14 flight.
P-Pod 6 deploy confirmed.
See when one of these bad boys deploy. Yeah, man. The cost to send up even a little small satellite, but I can understand. I mean, it's a lot of work. I mean, imagine getting one of these things wrong and a rocket lands in somebody's city or something. So I could definitely understand that you have to be, you know, pretty high level to do stuff like this. You can't just put something together and then sit out in the space willy-nilly. That's a good view of the Earth right there. Obviously, this thing is rotating, probably because they're about to get some on the other side. So right now, this thing is over. What is that? Australia? That's Australia. Looks like Australia. That look like Australia to y'all? Pretty sure that's Australia. Nice view of the sun right there. Yeah, man. Very good stuff, Logan. Look how fast that thing is moving. You see how fast it got past Australia right there? Right now it's going, so it slowed down a bit. Still at about 25,000 kilometers an hour. Still at 15,000 miles per hour.
Hopefully we'll get a visual as well. They just here confirmed over the nets that Prox 1 deploy was confirmed.
Awesome. So it's, oh, there's one right there. Here's one we can see.
Very exciting, another successful deployment.
Yep, so that is one of the satellites right there.
10 seconds from now, hopefully we'll hear the same.
And you can see the light blinking on it, getting ready to go. You see that bottom one right there, Matrix? That's the one that was just about to deploy. It's about to deploy in a moment. Boom.
And there you see the release on your screen of MPSat, a successful deployment and confirmed over the net.
That must be some serious math to be able to calculate precisely the speed to release that thing to where it just stays where it needs to be. Because you understand it still has that forward momentum.
In just about a couple minutes from now, due to the positioning of our camera, though, we will not be expecting to see this deployment.
New Zealand was the little one outside of Australia.
Is a versatile modular platform based on
I can believe it, Rez. Just a simulator.
SSC Hawaii.
On STP-2, OTV is hosting several.
I know, right? But it's just like how when we're in the car, like when you're driving down the interstate, and you're just cruising, especially if you have a new car that has some nice insulation and everything. It's just like, you know, when you look at a car next to you, you might be going 80, they might be going 85. It's like you're just chilling. So, it's the same thing. Even when it deploys the satellites, it's like they might as well just be sitting right inside the living room, just except for the weightlessness, of course, but that's pretty cool, man. Now, one thing to keep in mind, Matrix, like you can see how all of these things are sitting out. That's because it's way up there high. Right now, it's at 722 kilometers in the air. So all that stuff is contained within the fairing of the rocket when it's going up. So that's one reason why this stuff doesn't get damaged on the way up. It's all contained within the fairing. By the time it releases, that middle rocket is way up high enough to where there's very little particles to damage this stuff. They have to do it that way because the equipment is so sensitive. You know, they got to protect it. You destroy the purpose of the launch if it goes up there and is damaged and everything.
A little bit of confirmation, of deployment of GPIM satellite. We're now one step closer to changing the way we travel to and around space.
Awesome.
Coming up
So here's another deploy.
1 minute. Just next to it is another one of the cosmic satellites, and then there's a third one.
Yeah, man. So you see that's another level change.
Closest to the camera. So we should have 3 good views.
There's one right there. Boom.
First cosmic satellite.
So that's supposed to be the first cosmic satellite, they're saying.
Within a second or so of the timeline that was set up days ago, so everything looking good.
And that was within the second. Do y'all hear that? So they planned this thing out, and they just released that satellite within the second of when they plan to release it. So you're talking about planning an hour and 31 minutes into a launch, going, you know, 15,000 miles an hour. So there must be some good product calculus and trigonometry and all that other good stuff being thrown up in there.
The camera cannot see all sides of the cylinder. So we had a great view just now of the first cosmic deployment, but the next 2 coming up are out of view. Maybe
so the next 2 coming up, he's saying, is out of view. So I'll skip past these.
Way into its own
Uh-oh,
orbit.
let's check this one out.
About 10 seconds to go.
So that whole thing was just chock full of satellites. It's pretty cool how they do that.
Cosmic 2 Satellite 4, the
Should-
one we intended, is on its
So they
way
call that the
into its
Cosmic
own
2
orbit.
Satellite 4.
See a little bit of that
Matter of fact, I just
on
noticed you
there
can see
where
the
it's
names of all the satellites right down there.
It's attached on top
See it at the bottom there?
second stage. So, next
So
up
yeah,
we've
man,
got
this stuff is planned out to the T. Awesome. So we're coming up to the next launch right here. Now, I remember seeing this one last night myself because I woke up at like, I don't know, it was like, I don't remember what time it was, but I know I saw the last one. The last one that I left, it was number 24. But I was like, I'm so late into it, I'll just stream the whole thing tomorrow. Let me go through the comments again. Yeah, gently. Even though they know they don't feel it when they're in the car. Like I've done that experiment before, like riding in the car and throwing things up into the air.
well, we're just
That's
over
right,
100
scaling as
miles
well.
in flight. We've had
It's hard to
the
imagine how large the Earth
Cosmic
is.
satellite deployed 2-1.
Oh,
Altitude,
well,
that means
I'll
the
focus
next
on the
one
almost in that
right
comment
in the
gently.
middle there.
It's almost unimaginable, but
Panel with the,
we can imagine it if we try.
on it. That's Cosmic 2
I find that most flat earthers don't
You'll
really
see that
try.
one deploy coming up in just about 2.5 minutes.
How far they going in this orbit? Let me take a look and see. Let me look up the SpaceX page and see if it's there.
Mexico, central Mexico. We're contacting through our Texas ground station, and we recently acquired the second stage
STP mission.
ground station that we have at Kennedy Space Center out on the East Coast. So it's been 100.
Right, so it says,
up on the end of the first orbit, and it's been a great first orbit. And in addition to all the satellite deployments, as we showed you a little
Not sure the highest is going to be.
1/2 of the payload fairing on the fairing recovery.
But I know it's at 3 different stages, 3 different altitudes for all the different satellites.
Half of the fairing, the other half did go
And that's a
into
good point, by the way.
the way we're working it right now is catch one
Anacito,
and make sure that you
to make sure that they don't bang into the next ones. Of course, they got to have a nice, steady, stable orbit away from the other satellites.
So right now coming up T plus 1 hour 44.
Yeah, man. Look at that. I'm not sure what this loop is right there. No, he muted himself. I didn't mute him. A lot of times when people in the hangout, they mute themselves to make sure there's no background noise. You still here, Matrix?
Yeah, bro. I'm
Yeah, he's still here. He just, a lot of times we mute ourselves so that we don't have a background noise coming through. But since I'm talking constantly, I just keep myself unmuted. Yeah, a lot of people do that. You'll find that a lot in the hangout. So that's good manners. I appreciate it, Matrix. So like no background noise come through and stuff like that. Okay, Junior, nice to meet you. I like how this view looks. How when they flatten it out like that. So, you know, on a flat map, it looks like they're going up and down, but we realize, of course, they're going in orbit. So it's like they just took the globe and spread it out. So I like how that little pattern looks when you happen to spread the globe out. And you realize the bottom loop is really going around the curve. I don't know, I guess it's just like illustrations. Uh-oh. So it looks like this is the last deployment right here.
The equator in the middle of the Atlantic over the Ascension 9. They're just about 30 seconds away.
So
From
30
our
seconds away.
burn of the second stage engine.
All right, so then they're about to do another burn of this engine. I noticed there's 705 kilometers right now. So let's see what it does when they burn this engine again.
Preventing liquid oxygen out the drain tube, chilling the engine in, preparing for ignition. Now this is going to be about a 30-second burn.
All right, so they're about to burn the engine for 30 seconds.
Heard the report. Engine is chilled for the third burn.
So they chilled it. First they chill it to get it ready for the burn. Don't want it to overheat. And there's some of that foil you was talking about, Matrix, that you could ask SpaceX about, see what the material is.
We're spinning the engine, and we have ignition.
And you notice how wide that thing opened up, and even now you can see how wide it is. It's almost like it's going sideways at the at the nozzle because of the little atmosphere. You can see how hot it's getting that fast.
The mission objectives now require that we increase the inclination. We're also changing the orbit from about 700 kilometers up to an apogee of 6,000 kilometers.
So now they're changing the orbit as well, changing the inclination.
And we should have shutdown of the second
Awesome.
stage engine.
So I imagine that must be automatic. They can't be sending signals to it. That's pretty cool. Yes, that's kilometers an hour. That's kilometers an hour. So it's going right now 28, and you notice how that burn boosted up the speed there. Let's take a look at that. So it went from 25,000 kilometers an hour. So that's about 15,000 miles an hour to 28,000 kilometers an hour to about 17,000 miles an hour. So that burn right there boosted it about 2,000 miles an hour. But I noticed that SpaceX always does kilometers gently. So that's some good power there. So that's about a good 2,000 miles an hour. It boosted it right there. So they're both increasing the speed and increasing the inclination. So it sounds like it's making it a more elliptical orbit.
And we should have shutdown of the second stage engine.
And look at how the speed slows down almost immediately when a rocket turns off. Right? It shows the acceleration, captures the inertia. Once it's at that certain speed, there's no more force causing it to change. It stays at that same speed. Pretty good stuff. So that burst and that change in apogee. So right now I say 860 kilometers up from the surface, and it's steadily climbing. So we can see how that burst right there changed the apogee, so it changed the orbit. So now it's 534 miles up into the over sea level. 534 miles up. So some good stuff. So I don't think they're going to release anything else. It looks like all the satellites have already been released. And it looks like it wasn't the last one that I saw, because it was the last ones looks to have been out of view. Uh-oh. Uh-oh. So it's really climbing. That's what that big loop was. That big loop is they're making it climb extremely high. So it's moving away from the Earth. Y'all see that? So right now it's at and look at that gently. It must be ice. You see that right there? That definitely looks like ice to me. What do y'all think? Yes, definitely, Maxwell. Especially given the size of the Earth. Damn right, Rez. That's why the ET craft, they can nullify mass and make themselves massless, and they have no inertia. So they could just accelerate and decelerate at will. So this thing is really climbing, man. You see how it's going away from the globe right there? Yeah, man. So let's take a look at this for a second. So this is almost like the view that that SpaceX had with the Starman. Right now it's 1,460 kilometers up into the air. That's almost 1,500 kilometers up. So we're talking about 1,500 kilometers up. That's almost 1,000 miles up and steadily climbing. So it looks like they're preparing to get this thing to land, and they're going to put it at a very high incline. So then they can use the force of gravity to help slow it down. I bet you that's what they're doing. One interesting fact, y'all know that every time, like y'all know how when they send satellites, let's say they send the Mars orbiter out to Mars, or they send the Voyager out to Saturn or whatever, they use the planets to slingshot the satellite. And every time they do that, they either add to or steal from the planet's momentum. This is a very, very, very little bit. But like, let's say they slowing the satellite down to, when they send it out to Mars, they slow the satellite down so it could orbit up around Mars. So they send a satellite in front of Mars. The planet Mars slows it down by pulling it towards the planet, and then it maneuvers itself so now it's in orbit around Mars. So I think that's pretty cool. But in the process, it sped up Mars just a little bit when Mars was slowing it down. Mars, because with every reaction there's an equal and opposite reaction. But because of the differences in mass, the satellite slows down a whole lot more than Mars, but it does slow down a fraction of an amount. So I think that's pretty cool. You want to see that ice again, Junior? Give me a moment here. Let me see if I can find it. Unfortunately, I didn't note the... Oh, here it is, right here. Let me back up a little bit, so we'll be able to see the full thing. Right now, we're following the... when we get back to that point, I'll point out that dot. So this is the ice that Junior was talking about. And you notice it's right on one of the tubes. They mentioned cooling. I imagine they must cool that thing with nitrogen. I'm not sure though. Liquid nitrogen maybe. But yeah, I noticed that the ice is there after the burn, so it must be burning perhaps some of the exhaust from the burn. And it should break off any moment now. So the ice is at 2 hours and 45 minutes in, when it's going at 27,000 kilometers an hour. See if I'll speed back to when it actually breaks off. There it is right there. So you can see the exact moment when it broke off. Well, you can see it starting to peel away. And plus we're getting different angles of it. There it is right there. Haha. I agree, gently. They're looking at us like children playing with Legos. But I'm sure they respect the fact. I mean, I'm pretty sure any extraterrestrial civilization, they have to go through the same stage as well. You know, if you want to get a good perspective, look at the Star Trek The Next Generation episode called First Contact. And also there's another one. I would have to get the title of that one, but look at the episode called First Contact. When the Enterprise is observing this civilization that just, so in other words, they have their prime directive with it. They don't interact with a society until it reaches warp technology, until it reaches the technology where it can travel amongst the stars. So the society made their first warp engine. So now the Enterprise, they realized, they detected that, and they went to that planet, and they disguised themselves to live amongst the populace, but they got discovered. And it was very, very interesting to see how the population responded. I mean, it was an awesome episode. First Contact, Star Trek The Next Generation. And there's another one. There's several different episodes where they meet primitive civilizations. When I say primitive, I mean primitive compared to Star Trek, but maybe around our level of civilization sometimes. It is very, very, it's awesome, man, that show. Yeah, man. Awesome. Shout out to Isaac Arthur's channel from Rosowski. I'll zoom back up a bit. I really want to see what they're doing with this altitude. I believe that loop. So right now, by the way, somebody was asking, I think that was Gently, which loop we're looking at. So this loop here, this top one is the one that we're looking at right here. This top loop. And this little center line is where it's at right now. And I want to get to the loops on the planet again. And this is what we're looking at right here on the blue line. So right now it's in between Africa and Australia. It's steadily climbing. It's at 3,200 kilometers into the air. And it looks to me like like I said again, I didn't look into it in detail, but just based upon my reasoning, that they're gonna give it a very sharp incline. So then the Earth is pulling it back, and they're gonna use the Earth's gravity to slow it down, rather than having to waste fuel trying to slow it down. Because of course you don't want to crash it into the Earth going, 15,000. And as you can see, look at it slowing down. So as it's going higher, the Earth's gravity is slowing it down. Y'all see that? So right now it's at 16,000 kilometers an hour. It's steadily going down, and the altitude is steadily going up. So they're using the Earth's gravity to slow it down. That's some awesome engineering. I don't believe it's like the shuttle, but I don't know. I look mostly into the engines in the Falcon Heavy engines and the Falcon 9 engines, which is the 9 smaller engines nestled into the big funnel. But I never really looked into the engine on the top part of the rocket. So that would be something good, interesting to look into. I know the Falcon 9 rockets has 9 smaller funnels within the large funnel, but this one definitely seems to be one large funnel. And right now it's slowing down. It's under 17,000 kilometers an hour. You see it's steadily climbing. So yeah, man. So now it's at 5,300 kilometers an hour. It's just about to go under 15,000 kilometers an hour. So it's steadily slowing down as it's climbing. It looks to be back over Australia. So this thing is circling the globe over and over and over, just circling around. That's how fast it's going. Which reminds me of the ISS. I believe the ISS circles the globe, I don't know, every 90 minutes or something like that. And we're 3 hours in. So I think that's the third time I saw Australia. And does that have one more satellite it didn't release? Yeah, it does have a few more things to release. That's why it's going up higher. I'm going to jump out to when it releases more satellites. So it is more things. When I saw, we used to get in different angles, so I didn't notice there was still more on there. So now it's at 14,000 kilometers an hour. It's burning again. It's 6,000 kilometers up. 6,000 kilometers up, guys.
Again, this will be about 35 seconds long.
So right now it's 3,200 miles up into the air. 3,200 miles. That's almost 2 million feet, no, even more. That's 19 million feet into the air. So right now it's 19 million feet up from the surface of the Earth. 19 million feet. And the altitude is not changing, but it's burning. So it's staying. So it's staying at that same altitude, just increasing the speed. And of course they have to increase the speed at a higher altitude, because it's farther away from the Earth. If it's going slower, farther away, it won't be able to keep that same altitude.
Nice. Yeah, sorry to talk over you. We got confirmed good orbit, and now that we have good orbit, we are waiting for our final deployment of the DSX satellite for the Air Force at about T+3 hours and 34 minutes.
Or maybe I have it backwards, one of the two.
So far, it's been an exciting mission and one of many firsts, including the first Falcon Heavy mission for the Department of Defense.
Oh, so it looks like they're about to. Oh, this is for the Department of Defense, by the way. This last one here.
The longest satellite mission in SpaceX's history.
And they're saying this is the longest satellite deployment mission in SpaceX history. 24 different deployments. So I believe we'll be able to see this last deployment. So we down to the last few minutes of the launch. And we're about to have the last deployment right now, so we should be able to see this last deployment. This must be the one that I saw last night. Right now it's going 20,000 kilometers an hour. It's still 6,000 kilometers in the air. So 6,000 kilometers in the air, that's 19 million feet into the air. And 3,728 miles up. So that's 3,728 miles up. Yep, I think I had it back, because it's one of the two. I know the speed changes. So maybe as the higher up you can be, the slower you can go, because the Earth's pull is less. So there's less you have to fight against. There's less speed you have to maintain to get around the Earth. But one of the two. But I need to start looking into this more in more detail. I'm gonna start debating flat earthers less, which I encourage us all to do. Because one thing I realize, guys, all the time we spend debating flat earthers, especially when they're not going to listen anyway and dismiss whatever we give anyway, that's time we could be learning more about real science. That's more time we could be learning. That could have been times I could have been learning more about orbits and exactly how they work. So you'll probably find I'm going to spend a lot less time dealing with the flat earthers and more time learning real science.
What a beautiful image. 24 of 24.
Look at this departure right here.
Jesse, we made it. I can't believe it. Night of historic first.
See that right there?
Take us home.
So that was the last deployment right there.
34 minutes, 42 seconds.
Good point, Rez.
Complex 39A.
Is the heat from the thruster making the insulation move? I guess that would be the only thing, because there's very little particles out there. I'm not sure though, gently, but that'd be something good to look into. By the way, there's a SpaceX website. I'm not sure how much information they have about the rockets there. They seem pretty friendly. They seem pretty open. So I imagine they would answer any questions you ask if you wrote them.
But we just missed the drone ship, Of Course I Still Love You. However, the side boosters made up for that with a great return to landing zones 1 and 2 for the side booster.
Awesome, guys.
Wonderful landing there. Second stage went into orbit. We did 4 burns of the second stage. All of them were right on target.
Ah, pretty neat, man.
24.
So that was it, guys. Let me put the SpaceX logo while we chill. I'll go through the comments, make sure I didn't miss any comments. Yes. So you think it's the heat itself that's glowing, not the actual? I thought it was the actual metal, Junior. Like the metal or the material of the funnel is getting hot so that it's glowing. But yes, it must be that way at Coom. The slower orbit, the farther where you are. Just like how if you far enough away from the Earth, you can stay still and not fall to the Earth. You could just sit there if you're far enough away. You're not within the pull. So yes, the farther away you are, the slower you can go. The closer you are, the faster you have to go because the gravity is so strong it'll pull you right back in. I remember hearing about the analogy to where if you shot a cannonball fast enough, it'll go in orbit as well. I mean, notwithstanding the Earth, the drag of the air. So, what are your thoughts? On what do you say? What are your thoughts on that cinematography, Matrix?
It's pretty neat, man. Pretty neat. Pretty fancy editing and stuff.
I agree. That's pretty cool, man. They obviously put a lot into their presentations. In my experience, SpaceX is the first one to make it cool again, to look at rocket launches, right? Like I remember when they were sending people to the moon, and it was like so much, like the nation was behind it, and it was all on TV, and apparently it's like the world stopped that day. Like everybody was watching the launch, everybody was watching what was going on. So now they have like, it's like a live TV studio inside the SpaceX, like is a space company, but it has this news type PR firm, and people are out there viewing it and they're cheering, and so I think it's SpaceX made space cool again, right? And then Blue Origin comes along, and I think there's a third one that's in the running as well. Yep, Akum. What balloons the insulation? What do you mean, Junior? I was pretty good at physics in school, Akum, by the way, but it's been so long I gotta catch up. Let's see if I could try to find a spot that says that. But or maybe I should have marked. I don't even know if you can mark certain things inside. See if I can find a nice burn spot. So we know it burns when it goes from 6 to 7.
The equator in the middle of the Atlantic.
Yep, I do see it moving right there.
At the equator later
Right?
because
Yep.
while the earlier
So it
burns
must
are
be.
increasing
But the fact is, though, by the way,
mission objectives
so if you look
now
at this, the nozzle is connected, of course, to this stem right here. And the stem, the foil is connected to the stem. So it doesn't have to be necessarily vapor or gases from the thrust that's making that happen. Simply the force of the thrust coming out the nozzle could shake the nozzle, and we could simply be seeing the fact that the aluminum or whatever it is connected to the nozzle. You see what I'm saying? So if the nozzle is shaking, my hands shake too. So that could be what it is. That's all. That could be what's going on. But like I said, I didn't look at it in too detail. I spent too much time debating flat earthers, so maybe I'll look into that next time. But that's what I'll say it is. The nozzle shaking because it's putting out that thrust. So the foil is connected. Looks like my hand. So the foil is shaking. So it could be as simple as that. Doesn't have to be the fumes necessarily hitting it. I agree, Rez. I don't know what it's made of, but obviously it serves its purpose. And of course, when it's going up into space, it's within the fairing of the main rocket, so it's not going to hit a lot of turbulence anyway. And by the time they release the fairing, the atmosphere is thin enough. If there is any atmosphere, there's not a problem. So it's pretty cool. But Matrix brought that up. I just challenged him to look into it himself because I've learned that whatever I tell him, you probably won't believe it anyway. Seems like you ask questions really Matrix not. And it's common. It's something common I see from flat earthers. And you can let me know if this is true for you. I'd appreciate your answer. Like I noticed that flat earthers I've observed and interacted with, they don't ask questions to really learn an answer. They ask questions just because they think there is no answer or because they think it's fake and that proves it's fake. So let me ask the question and I'm just showing it's fake. So let me ask you, when you ask the question, what's that stuff that looks like foil made of? How can it withstand the G-forces? Is it that you're certain this is fake and it can't be real, and you just pointing out how that's fake? That's like plywood, plastic, tape stuff. It wouldn't survive it, so it's fake. Or you really want to know what it's made of and how is it surviving? What would you say?
Bit of both.
A bit of both. What's the honest answer? Sounds like. So awesome, guys. All I really wanted to do, just show the rocket launch and get a chance to look at it, as well as just focus on some science for a change, focus on some scientific advancement and some technological advancement, and I'm going to start doing that more. So Saturday, I'm going to have a show Saturday at around 11:30. I'm trying to time it so it's after, like I know Jose is on. So I'm trying to time it after his, and I think last Saturday he got off at 11:30 my time. So that's 11:30 Central Time. So the plan is I'm going to start it at 11:30 Central this Saturday. And what I've been doing, I've been reading the book Stellar Atmospheres by Cecilia Payne. I don't know how many of y'all know, but she studies stars, the spectrum from stars, and see what I'm starting to learn from reading her book. She took new advances in quantum physics and radiation and things like that, and applied it to observing the radiation from stars. And she discovered, and that's how she discovered that the stars were, at least I'm still like in the early parts of the book, but what it's looking like, that's how she discovered the stars were not made of all the different elements they thought it was, because I didn't realize that atoms can reach excited states where it absorbs some energy, and the electron might jump up in orbit, and eventually an electron could jump off the atom, and at that point it'll be sending back different lines in the spectroscopy where it can look like a different element, but really it's the same element. And once that element absorbs another electron, it'll be clearly the same element. So she seems to be the one who combined several sciences to really look at the fact that what we thought were other elements were simply different excitation states of the same element. So the absorption lines were a bit different, and the radiation lines were a bit different. and that's why, because of the different excitable states or neutral states of the electrons in the atom. So it's pretty cool. So I've been reading that. I've been spending more because I have ideas for different flat earth videos I can make, but I've been delaying that and actually reading real books from real scientists and things like that. So that's what I plan on talking about Saturday. Maybe I'll open it up afterwards to if some flat earther want to come on and debate or something like that. But I'm going to spend the first maybe 30 minutes at least just talking about what I'm learning about how Cecilia Payne and other scientists apply the knowledge of atoms and electrons and the excitable states and ionization, and apply that to spectroscopy and revolutionize our way of understanding stars and understanding what they're really made of. So it's pretty cool. Awesome. So y'all be cool. Is there anything you wanted to talk about before we left? I could give it another 20 minutes if you wanted to talk about something, Matrix.
Yeah, sure. Give me a second.
Okay. So awesome, gently. It'll be here tomorrow, but I'll stay on another 20 minutes and give Matrix some time, maybe a little bit more, depending on how the conversation is. But I definitely plan on getting some sleep tonight, so no more than the bottom of the next hour. But I'll see what Matrix is talking about for a while. But I hope you enjoyed the look at the launches, gently. And congrats to SpaceX, congrats to Elon Musk. Yeah, man, some good engineering, some good stuff. And the funny thing about it is, when I was starting thinking about changing my focus, then this launch came like a few days later. So it's like it's kismet. It's like perfect. So I was ready to talk about this launch so I could talk about something else.
How do I present, man, on this?
Well, I'm presenting, so that's probably why you can't present. But now try presenting, and what you want to do is just click your icon, so the little white thing shows up at the bottom, and then it'll say present now. So just click your icon in the Hangout, and then click present now. It should show up at the bottom in this little white bar on the right side. It should say present now. Awesome. Right? So that's what Matrix Media is presenting right now. Okay, so what do you want to show us? And I'll go ahead and make it bigger so everybody can see. Give me a moment here. Let me adjust my OBS here, and I'll make your presentation bigger so everybody can see more clearly what you're talking about. So I'll let that disappear. I'll take the Hangout, I'll unlock that, and I'll cover my books momentarily, just momentarily. Or not my books, but my updates. There we go. Okay, so you're presenting. Everybody can see what you're presenting. So what do you have to tell us, Matrix Media?
You guys saw that? Just
So,
look, just have a look.
Or play it one more time. Awesome. So what do you have to say about that? What you got?
Hold on. You guys hear me, right?
I can hear you now. Yes.
All right. While you was talking, this took me like 15 minutes to do. If I dedicated an hour to this, I could have you believing that I went to the moon.
Good for you, man. Some good that you have that cinematic skills. Congrats on that.
Listen, I'm not even good at editing. This is what I'm trying to tell you guys, right? I'm not saying that just because I'm able to do this, therefore it's fake.
Mm-hmm.
But if a person that doesn't have that much skills, that literally learn editing in a month, could do it, imagine what billionaires could do, right?
Well,
just think about that.
Well, I could imagine, man. Let me show you. Let me show you one of the things I'm talking about. Give me a moment here. Let me show the web thing again. A moment here. Let me see if I can find it first. One moment here. So, X-Men, Dark Phoenix. I'm not a fan of this movie, by the way. I saw it. It was alright. Well, like I say, I liked it. Yeah, not a big fan. Fan enough. Fan enough. Give me a moment here.
destroyed everything it ever until you.
Let me see if I can find that part of the movie.
Well done. She's not.
Oh, so look at this right here. Let me show this again.
Help is on the way. Doing space missions now. Cool.
Boom, look at that. I can certainly imagine. That looks pretty good, don't it?
Cool.
Looks like some people flying out in space.
Heat signatures rising fast.
That looks even better than SpaceX's, I guess. Some might say. So these people right there in the space, out in space. Looks pretty good, right?
Are you presenting?
Oh, I'm sorry. I forgot to present to you in the Hangout. I'm sorry. Give me a moment here.
Hello, Jean. Who are you? The better question is, who are you?
Something's happening to me. When I lose control, bad things happen. But it feels good.
That
Boom.
power
Awesome.
destroyed everything it ever came into contact with.
So it should be presenting now. Let me know when you can see it. You able to see mine in the Hangout? The trailer playing?
Help is on the way. Doing space missions.
You can hear me, Matrix?
Cool.
Yeah, I can hear you. I just, for some reason,
Maybe.
yeah, it was pinned. It was pinned. I got it.
Okay, you got it now?
Yeah, it's good.
You can see it. That looks pretty good, right? So right now the X-Men are about to go into outer space.
Cool.
Blasting off. Looks pretty good. There's a space shuttle. That looks almost like the SpaceX launch right there. That part right there.
Doing space missions now. Cool.
But I wanted to pause it at. Right there. That looks pretty good, right? That looks almost like the SpaceX launch. What do you think? You able to see it?
I didn't see the whole thing. The whole SpaceX launch.
No, I mean right here. I'm saying the one I'm presenting right now.
Yeah, but I don't know what to compare it to because I didn't see the launch to the entirety. Like I didn't see the whole thing. I just
I mean just the parts we were skipping through.
Yeah, well, I guess the kind of Earth looks kind of similar.
Yeah,
I guess.
that's pretty cool. Oh, there's a movie called Gravity. Let me look that one up. Gravity movie. Here we go. So they're out there spacewalking. I saw part of this movie. It wasn't good enough for me to get through. That's pretty good, right? That looks something like the astronauts, I would say. Looks a little bit more CGI to me, but
I mean, for whatever astronauts are supposed to look like, I guess it does look like astronauts.
Yeah, looks pretty good to me, I think. Let's look a little bit farther, see if maybe they show the Earth a little bit. Yep, there's the Earth right there. Yeah, it was going at a sharp enough angle, I think.
That's an order. Sorry,
Awesome, gently. Glad you enjoyed it. Yeah, so look at there. Got the Earth behind them. You can see the curve. Yeah, it looks pretty convincing. Looks pretty real. You can see the fall stuff like on a satellite. That's pretty good, I think.
But notice how solid it looks on the animation, right? Notice they're not flapping around like bags.
Yeah, it looks pretty good. And probably in this example, they probably have better technology. Maybe they could control themselves a bit better. But that's correct. It does look less flapping around than I think I've seen real astronauts look. But yeah, looks pretty good, right? Pretty convincing. Yeah, so I agree. If somebody put their mind to it, they can make some pretty convincing cinematography. So we definitely in agreement there.
I'm just saying, just take it to consideration, guys. You know what I'm saying? If it's a deception and we're saying it is, they're supposed to deceive you. That's.
I mean, why don't you just? It sounds like you're not really making a point. So if you want to make a point, why don't you simply honestly make your point, and then we could talk about it.
No, I already did. I mean, my demonstration of how easily I made a rendering.
And I agree with
You know?
that. I agree. It's easy to make some CGI stuff. So we're in agreement then. If that's all you want to say, yes, easy to make some CGI stuff.
Yeah, that's pretty much it.
Awesome. We're in agreement then. 100%. Anything else you want to talk about?
Nah, man, I'm good.
Awesome. Sounds good, man. So, awesome, guys. I wanted to look at the launch. I gave Matrix some time to talk about what he wanted to talk about. Did you want? I remember you mentioned one of the alien things too. Did you want to mention some of the alien stuff I mentioned?
Oh, you was talking about aliens?
No, I'm saying in other videos I mentioned aliens, and I noticed you making comments about it in the comments about that in the comments of the video.
Yeah, about the aliens.
Is there something you want to say or ask about that before I went?
Nah, I mean, just kind of, it's normal curiosity. Like, how would you know what's the difference between you in a dream, right?
Mm-hmm.
Or you actually having these events?
It's a good question. So, one thing you can do is simply test it in experiment. So, for instance, one of the out-of-body experiences I had, I wanted to test myself, and I wanted to test one of my friends. And I can actually stop presenting now. I wanted to test myself, and I wanted to test one of my friends. So what I did was I went out of body without telling them. So I didn't tell them I was going to do this, and I just went out of body and to meet him. And one of the things I did was you could change the way you look in a non-physical state. You can make yourself look however you want. So I dressed myself in this long white robe with this gold band around it, and which I've never worn a white robe with a gold band around it in my life, and I don't think I've ever even seen that type of dress before. But I thought, let me just think of something different that nobody would think to see somebody wearing. And I thought to tell them this kind of was like I made up some kind of word to tell them. I can't remember the word, but I made up some strange word, or maybe I thought about some odd thing to tell them about, like a pink elephant or something. And I went out of body and met him. So this experience, I wasn't fully conscious. My consciousness was a bit cloudy, but it was enough where I knew I was there. I knew I was meeting them, and we had a brief conversation, and then the experience ended. So I remember I didn't tell him anything about I was going to do this experiment, and we used to talk every day at this point. My friend named Lewis, so a cool guy, and the next day we talked as normal. We was talking about whatever, just whatever we normally talk about, just small talk and stuff. And then out of the blue, he said, "Hey D," he said, "I saw you out of body last night." I said, "Really?" I said, "Well, what happened? Tell me about it." And he said, "You was wearing this big stupid white shirt with this gold band in the middle." I was like, "Really?" And he said, "It seemed like you were drunk." So that's one experiment I did. So to me, that's evidence, because I didn't tell him anything I was doing, yet he correctly confirmed that I met him out of body, which was my experience as well. He correctly confirmed I was wearing this long, he didn't call it a robe, he called it a stupid long white shirt with this with a gold in the middle of it. But he correctly identified that I dressed myself in this long roby, shirty type thing with gold in the middle. And I knew my consciousness was not clear of that OBE, and he correctly identified that I was unclear by saying it seemed like you were drunk. So that was one of the experiments I did. So when I go out of body and I have that experience, and I go out of body, and let's say my very, very first out of body experience, I went out of body and I saw my mom, and I saw kind of things she was doing in the kitchen. And I wouldn't say that's not much of a proof for somebody else, because your mom does normal stuff in the kitchen. She was like cleaning, washing the dishes and stuff. But to me, it was clear as day. This is one of my very, very clear out-of-body experiences. And I saw exactly what she was doing, and I told her what she was doing, and she confirmed it. Not as strong as the one with Lewis, but it's evidence to me. Another experience I had was I went out of body to Big Ben the clock. So the teacher was telling us about Big Ben the clock in elementary school. And this was like let's say a year or two into me going out of body, and I used to just walk around the neighborhood and fly around and stuff like that. And finally I realized, you know what, maybe this is something really going on. Maybe I could really go somewhere and explore it. So I thought, you know what, I'm going to go to Big Ben. The teacher was talking about Big Ben the clock. In school, all they showed was a picture of the clock, just like portrait of the clock, basically. So then that night I intended to go out of body and to Big Ben the clock, and I made it to Big Ben the clock. And I remember what the environment looked like. And when I got older, and now of course we have advanced cameras and people take big wide angle shots of stuff, and I saw a picture of the area of Big Ben, and it matched what I saw as a kid. So when I take experiments like this, and then let's say I go out of body and I see an alien, and it's the same type of experience I had when I met Lewis, and it's the same type of experience I had when I saw my mom. It's the same type of experience I had when I saw Big Ben. Then I conclude, well, this is a real experience as well. Then let's say I start reading books, or I start doing radio interviews or things like that. And somebody contacted me from the other side of the planet, and they say, hey, you know what? I had this same experience. Or I pick up a book that was written 10 years ago. Let's say 10 years before I had the experience. I found OBE books that was written before I was born. And I read the book, same experience. I go out of body. Like I remember I went out of body like in the non-physical states. Like the non-physical realms are pretty stable. There's some environments that have been coordinating in a coordinated way built. There's universities in the non-physical dimensions. There's parks and all kind of architecture that's stable. I mean, it's non-physical, but it's there. You can go out of body and go there repeatedly, and you can meet people there and communicate with them. And there's one area of the non-physical I went to. I explored it, and the whole experience is a different story. But suffice it to say, I went to this certain location out of body. I explored it, and a few years later, I got this book by this other out-of-body explorer, and he was a good graphics guy, and he made a graphics of this library in the book. And I kid you not, when I looked at that image, it was as if he had a camera and was standing right where I stood. The way the bookshelves was, the way the walls were, the way he described it, it was clearly in the exact same place. With my experience of being there, and his description, as well as the image that he had, it perfectly matched my experience at this place that other out-of-body experiences talk about as well. Robin Monroe talked about this area called the Park. He talked about this area. I visited that area. Bruce Moeen talks about that area. Several out-of-body explorers visited that area and talk about that area. The descriptions are the same. Some of these descriptions were made before I was born. And I haven't seen anybody talk about that particular area that I went, this particular area of the library, and this sort of Akashic Records type building. But the image he had in that book that he made with a computer graphics program, it perfectly matched what I saw. It's like awesome. So when I take these experiences that I can confirm, then I have a baseline by which to judge other experiences when I see ETs, or when I go to other planets, or when I went to the moon. And I discovered there was a base. There's a base on the moon, an underground base on the moon. So when I have those experiences and I judge my clarity, I judge the way the environment looks, I judge everything, and I compare it to these experiences that I was able to verify, then I accept that experience as real. I've also had dreams. So I know what a dream is, like a regular dream where I'm running from a pink elephant through my bedroom, and I wake up, there ain't no pink elephant in my bedroom. So I know what a dream is. I know what a lucid dream is. I've had lucid dreams before. And I know what out-of-body experiences are. So to boil it down, you experience all these things, and you test it, and over time, you start to learn how to discern just from experience. Just like any science. Does that answer your question?
I'm sure. I guess. How do you deal with talking to people about this?
I don't know what you mean.
I mean,
and by the way, before I answer this next question, let me look into the notes and I'll catch up on the comments for a moment because I want to focus on your answer there. Let me see here. Good point, Gently. Gently is just saying, going back to your CGI comment, yeah, you could say it's CGI, but what about the people that's viewing it from the ground? Like I showed you earlier,
they could be shooting it up. They could be shooting it up, dumping it in the ocean somewhere, far that we don't see it and
Mhm.
just CGI the rest.
I see. Well, this is what you can do. Well, matter of fact, I'll let you think about that. How can you prove or disprove that? Do you think?
That's the thing. You're not supposed to disprove it. You know.
I didn't ask that. I asked how can you prove or disprove that?
How would you be able to disprove it?
You can't think of a way to prove or disprove that?
I just told you how.
How? I didn't hear you. I'm sorry.
I told you that they launched the thing that they're gonna launch, right?
Mhm.
They far away they dump it in the ocean, right? It goes around like those NASA things of those loops that they dump it because we're gonna assume it's already out of space, and the rest of the imagery is CGI.
So right now, what you did was you simply reiterated the claim you made, or the possibility you made. You did not answer my question. So what I'm asking is, how could you?
You told me how was it a possibility to fake it, and I told you how is it a possibility to fake it.
That's
Now
right.
you're asking me for some sort of confession. Like, are you expecting me to get an email?
Right.
Or something?
So maybe try to listen to what I'm saying. Like really listen to what I'm asking you right now. Are you ready? How could you prove or disprove that? Like, do you have proof that they're doing that with the dumping it in the ocean and CGI? Like, do you have proof that they're doing that?
It's a conspiracy, bro.
Do you hear what I'm asking you? Are you able to hear me talking? Like I'm asking, are you able to hear me talking right now?
I'm hearing you, bro.
All right.
It's a conspiracy. I don't know what kind of proof you expect.
So listen to my question. I'm asking, have you proven or disproven that? Like, do you have proof of that? Is what I'm asking.
Do you have proof what you're showing is real?
Okay,
Or you just believe it?
so yeah, man. I'm just gonna. If you're not willing to have a discussion and actually answer a simple, basic question, you could just go, man. You could just go, man. You could just go. So, so I'm not gonna deal with the nonsense anymore. So let me take a look at what we got here. I guess it could be explained as observation from the ground. Define out of body. Is this a spiritual soul thing, a metaphysical thing, ghostly? Well, I guess it depends on how you define it. I'm starting to think of it as non-physical science. So if you look at the book that I have flashing on my channel right there, Travel Far. That's the first book I published. It's on the out of body experience, and is basically from a sort of a metaphysical point of view. But I'm starting to recognize it as a science, as non-physical science. So yeah, so I'm gonna do more experiments. I'm gonna get my skill up to a higher level, and do some proofs that, like, I've done enough proofs, like y'all heard me earlier, so that I accept that as real. But I'm gonna devise some proofs that I could bring it to like a university or make it some kind of scientific paper. So, in my experience, it's really just a different frequency of matter, a different frequency of energy, and heretofore has been relegated to like the occult or the mysticism or things like that. But really it's just, I think, science. Just like how maybe a cell phone might be mysticism if you go back enough years into the past, but really we know it's just science and waves of electromagnetic energy and batteries and so on and so forth. So I'm gonna in the second edition of Travel Far I'm working on is gonna approach it from the scientific perspective, but it's probably gonna be a few years for me to finish it. But before I finish it, I'm gonna do more experiments, and I'm gonna put out like some journal books where there's journals of me traveling. But really, I see it as just a different dimension. Awesome, gentleys. What you can do, let me give it a link to Travel Far, because it's right online. You can go online and read Travel Far yourself. Give me a moment here. I forgot I already have my webpage up here. So all you got to do is go to my website here at DarrylEberryJr.com. I'll put it into the chat right there. And I would think Fight the Deception would call that keeping it real. So you go to books, go down to the Central Curriculum Travel Far series, and just hit HTML on the right, and then you can see Travel Far right here. So the first part of the book is my experiences. You can read about experiences I had up until about 2001. And the second half of the book is the theory and methods, where you can learn actually how to have the experience yourself. So I give the theory, like my basic understanding of what causes it. I give the techniques I use. I give the basics of how to develop concentration and so on and so forth, the tools you need. So you could definitely go ahead and practice yourself and learn how to do it. I may open up a class again in the future to guide people in learning how to do it, but you know, it takes a lot of time and effort. But it's all right there. And if you get good enough, man, then we can go ahead and do some experiments. I plan on doing that again. I actually had a research study. I did 2 research studies so far. One research study, taught people how to do it and confirmed that the techniques was real. And the second research study, we did some experiments meeting together and having experiments, and we had a few successful ones. So if you're interested in doing that, I'll definitely be up for it. So, but I plan on going back to the rest of his questions. But if he's not willing to answer simple questions, a simple, plain, straightforward question, again, I'm going to spend less time dealing with these flat earth believers. And by the way, Fight the Deception, we agreed to meet again. You don't want to meet again, so you're not one to talk about keeping it real. Let me tell you. No, I don't. Wikipedia is not a good source. I've already told you that when we talked. When you want to actually get together and talk again, you let me know. That's keeping it real. No, that's not true, Mies King. I was literally asking an honest question. So let me ask you. He's saying that they're dumping it into the ocean and the rest is CGI. So let me ask you, Mies King, how would it be possible to prove or disprove that? What would you say? How would it be possible to prove or disprove that? Oh, now Wikipedia. Oh, I missed the 9. I'm sorry. Yeah, go ahead and link it. Fight the Deception. Go ahead and link it. That's fine. Or if you can't link it, just send it to me in my comments on my channel, or send it to me in Discord. That'll be fine. I call it what you want, Matrix. I'm not going to waste time with you anymore. If you can't answer a straightforward, simple question, then I don't see any point in talking with you. I ask you just very simple, straightforward questions. Do you have proof? And how do you think you can prove or disprove it? If you're not willing to answer it, I don't see why you're here. You go somewhere else. I don't think you have to install anything. Now just send it to me on my channel. Like if you go to my channel, there's like comments or community at the top, and you can make a post right there. I'll check it out. But I won't answer the question for them. I'll let them think about it themselves. If they're not intelligent enough to answer the question, then I don't see any point in discussing with them anyway. Or if they're just unwilling to answer the question, then I don't see any point in discussing it with them anyway. So one or the other, I'm not going to waste my time with it. Okay, come on, Mies. Just if you look in the description, just go to the description. The link is in the description. I believe you could just click the link and it'll let you in. So we'll see if uh, so I'm just going to ignore your talking now, Matrix. You had your opportunity. You didn't want to answer a simple, straightforward, honest question to have a discussion. So I'm going to ignore your comments for the rest of the night. You could try another day, just to let you know. Hey, what's going on, man? Oh, I forgot I have to click accept. Awesome, Mies. Welcome. So we have Mies King. I'll spend another 20 minutes on, by the way, so at the bottom of the hour. So I'll let y'all know we're on the 19-minute countdown right now. At the bottom of the hour, I'll go ahead and close it up. So, what do you have on your mind, Mies?
What's up, buddy? Just
doing good.
Can you hear me?
Yes, I can.
Okay. Sorry, I'm on a cell phone, so I didn't
No
have
problem.
to.
I can hear you fine.
And I'm very, very, very new to using the Hangout thing. So,
Oh, no problem. You're doing well.
Yes. But I was trying to agree with you. Like I like listening to some of what Matrix Media has to say. But yes, you did ask him a very simple question, and he did dodge it on there.
Yeah.
Let's be real.
Yeah. So let me ask you. Do you
sure.
have proof yourself? Like, and I apologize. I don't think we talked enough. Do you accept the Earth as a globe, or are you a flat earther?
Currently, I lean towards flat Earth.
Okay.
If the globe was proven to me, I'd be cool with it, bro. Like, you know,
Okay.
it's not going to ruin my life. I would have no problem conceding it. But me personally, I am currently on the flat Earth side.
Okay. So looking at that premise, because people are there, they see something shooting up, but the idea is that, well, maybe they're just shooting it up so high it's going into the ocean, and the rest of it is CGI. Do you have proof that that's going on?
Absolutely not.
Okay, so let me ask you this: given that that's a possibility, how do you think you can prove or disprove that?
Man, it would take us like going out and parking in the ocean and trying.
Thank you. Exactly. Very simple. That's all I was asking, and you answered it in 10 seconds. I mean, yeah, simple as that. So one way you could prove that they're really dumping this stuff in the ocean is to simply get a camera, get a boat, drive out, and record it. Simple.
Yes, sir.
Because we have recordings of the things landing on the launch pad, the booster, and we have recordings of the other thing just steadily going up in the air from the ground. But of course, you can only see it so high. But if you're saying that's all CGI and really all that stuff is dumping in the ocean, get on a boat, go in the ocean with a recorder, and prove it. It's very simple, very easy. That's all I was asking. If you're not willing to answer that, you can go. So thank you for being honest enough to answer a simple question. So that's all I would say. If you accept that, if you believe that it's fraud, and he wouldn't even say if he has proof or not, but if you believe that that's what's going on, then why don't you go and check it out and get the evidence? If you're not willing to do that, then I don't really see any point in conversing that with you anyway either. But I don't know if you were here earlier, but one conversation I had with Matrix was he said, let me see how to he was saying something to the effect of, you can't just believe what anybody says, or you shouldn't just take people's word, or people don't know things, or people just say things, something like that. I can't remember exactly, but you could go back on the video and see. So, and it seemed like he was referring to me believing them about the space launch, right? So I asked him, I said, well, you said in the hangout the other day that you can't go to Antarctica. I said, where did you get that from? That you can't go past a certain latitude or whatever. He said, well, I got it from the treaty, from the Antarctica Treaty. I said, well, have you read the treaty? Where did you get that? Where did you get about the treaty from? No, I didn't read the treaty. I got it from a YouTube video. I got it from a video. Okay, so you could accept what somebody says from a video, but there's a problem with me accepting what somebody says from a video. Oh, it's not one video, it's multiple videos. Well, I'm accepting what thousands and thousands of scientists have said over thousands of years, building on science multiple. So it's a problem for me to accept mainstream science, which is built upon decades and decades and centuries of constant progression, but you listen to 20 people on YouTube videos, and suddenly that's good. That's good enough. So, you know what I'm saying? So, and when I challenged him, I said, you're saying they can't go to Antarctica. What's your proof that they can't go to Antarctica? He says, well, I haven't seen a video of people going there. I said, well, just because you didn't see the video don't mean it's not happening. But Soren G came and showed us that there's a race around Antarctica every year. And he said, "Well, I don't believe that. You have to take me into outer space." So even that's not going to be enough. So you can understand why I'm not willing to waste time with him anymore. So yeah.
Yeah, but like for me, man, like one, I hate flat Earth. It sucks. I don't want to believe this stuff. I can't stand it. But while I personally believe this to be true currently, I don't think there's any proof in it. For me, I don't think it's worth debating. I like talking about it. But there's nothing I'm going to be able to do in Google Hangouts or on YouTube to convince anyone of this. And if I'm being quite honest, I don't want to convince anybody of this. I don't like how this makes me feel. Why do I want to shove this on other people? You know what I mean?
One of the things I would ask you to look into, because it sounds like you're kind of on the fence, or at least you're open-minded. Let me pull up something for you real fast, and you could and maybe you could explain this to me from a flat Earth's perspective.
Go ahead. Yeah, go ahead.
Give me a moment here so I can find this image. Maybe I didn't save this image yet. Give me a moment here. Let me get it from my...
Like I will add while you do that that I am coming at this thing from a biblical perspective. Like I firmly believe that God is real and that Jesus is his son, and I believe that long before I came to flat Earth. And the only reason that I even bothered to look into flat Earth or take it as a possibility is because like I saw a lot of Reb Skiba's stuff saying, or at least his arguments for why the Bible describes the Earth this way. But I really struggled with this, and like for the first year and a half of knowing about flat Earth, like I wouldn't even tell anyone about it that I was looking at it because I thought it was so preposterous. But I couldn't reconcile what I was reading in the Bible. I was like, man, like either everything I've ever believed is wrong or my faith is wrong. And if it weren't for these strong arguments that the Bible suggests this, I would have never even looked into the rest of it.
So it's really a religious belief for you, really?
I believe that there is evidence to support it. There's no proof. There's evidence to support it. And there was enough for me to legitimately look into it further. But if it were shown to me that absolutely 100% the Earth is a globe, like I said, I'd still be cool with it. It's not going to crush me. I'm fine with it.
And obviously the videos of the launches is not enough for you, obviously.
No, sir.
Let me ask you this. Are you able to see this image there on the... Oh, I forgot. Am I presenting? I'm not presenting, am I? Oh, you're able to... Hold on, give me a moment. Let me present this real fast.
I just see D right now.
So,
I could...
Give me a moment here. Let me present real fast. I keep forgetting to have to present to the people inside the Hangout.
No problem.
So let me bring up my website one. Let me paste this here. And this is from somebody I met yesterday, a cool cat named, let me see what his name is here. Named Bash on Discord. And so I'm going to present this image that he shared with me. That's sort of that he hasn't been able to get an answer for from any flat earthers yet. So I'm going to present now, present your entire screen, this window here, boom. So check that out when it shows. So this is what we have. We have the southern tip of South America on the left. We have the southern tip of Africa to the right, and we have the south part of Australia to the upward in the image. So how do you explain the fact that people at these locations on the basically the opposite triad of a flat map see the exact same star formation and the exact same twirl of the southern pole?
Okay. Before I answer, all I will say is I'm only going to give you my thoughts. I have no desire to convince you. I don't hate you because you're a global believer.
Let me clarify something. I'm not a global believer. I mean, it's simply a fact that there is a globe. All you got to do is look at the evidence. So there's nothing you can. So I mean, the weight of evidence you're going to have to overturn. Nothing you can possibly say can overturn. But that's a whole other discussion. But I'm asking your point of view. I mean, how do you explain this?
Okay. When I look at this, all I think is, man, how do I know that, one, they actually see this from these locations? This is just what I'm thinking. I'm not discounting this. I'm not saying it's not true. I'm just saying this is what's happening in my head. Okay. And then, like, I still struggle with the idea of the Southern Stars, and I haven't been south of the equator to look, so I don't know. But that's just what happens with me. Is how do I know right now that this is actually what's being seen in these locations? So
your position is simply that you don't really know that people are seeing that. It's just something I'm saying at this point.
Right.
Okay. Is it important enough for you to actually travel to South America and travel to Australia and travel to South Africa to see for yourself?
No.
Okay.
But that is why I will not be on any flat Earth debates trying to convince anybody else of this insanity.
I find that quite interesting. Like for instance, Matrix was holding on to the idea that it's possible they're faking it, right? But he wouldn't even consider how you can prove it, right? He wouldn't even answer or consider, obviously, in our discussion, how to prove it. Even either he was unable to consider that or unwilling to even say, well, you know what, I can get a boat and go out there and see if it's really crashing into the ocean, right? So this is one thing that would definitely throw a wrench, or that I even say definitely would. I guess say definitely would throw a wrench in the flat earth believer's mind. Definitely, because the person who gave me this image, I asked him, how did you get these images? Because this is not the original. The original one, like he knew somebody who was into professional photography. And of course, just like how we have, there's flat earth channels and round earth channels, I'm sure you're aware that there's scientific communities and there's photographic communities as well, where a whole bunch of photographers meet together for conventions and they have their web groups online and stuff. So he knew someone who was a part of this group. So he had his friend, who was a photographer, talk to his photographer friends, and he knew a photographer who was in Australia. He knew a photographer who was in Africa. He knew a photographer who was in South America. And all of these professional photographers took photographs from their location and they sent it all to him. And he was able to show that they see the same thing in those locations. He was able to do some kind of sort of mesh where you can see that it was precisely the exact store locations, right? So he took the effort to do that. So to me, if it's this important, especially if it's biblical to you. I mean, this is about the reality of God and the reality of the Bible, heaven and hell. This is existential stuff when you get down to it from that level. It's not important enough for you to go to these continents and see for yourself and say, hey, look, this is wrong. We see different things. I could see a totally different star system from South America than I do from Africa. This is evidence for the Bible. I would just say to me, I don't understand that. When the solar eclipse happened, I drove three hours to go see it. I drove like I don't know how many hours to go to this observatory I guess I can't say but on another show we talked about it. I went to the Cherry Observatory thing in Pennsylvania, and I saw the arm of the Milky Way, and I was able to see some things, and I risked my life to out of body. When I didn't really know, when I was a kid, it was just something that happened. But at a certain age, I realized, I'm going out of body. That's what's going on. I was like, man, if I do this thing again, where am I going to die? I don't even know. So for years, I stopped doing it. But at a certain point, I was like, man, I could really go meet dead people? Are you saying I could really confirm what happens after you die? And I had to make a conscious decision, because nobody could really say whether I'm going to die or not. So I thought, am I going to keep doing this and risk dying? Or am I going to find out what really happens after you die? Am I going to find out what the afterlife is like? And I thought, well, you know what? I'm going to risk dying. And I did it.
Yes.
And I met my grandmother after she died. I went to that park place that I mentioned earlier, and I did a lot of stuff out of body that I was able to do, but I had to risk my life to do it, at least in my mind. I know now that you're not going to die. I know now that it happens every night. A lot of people don't realize that I met people out of body and confirmed things. They didn't really remember it. But, you know, you're still able to confirm things even if somebody can't remember it themselves. And they can say, hey, you know, this really happened in my life or whatever. So, yeah. So, but I had to risk, in my mind, I had to risk my life to do it. That's how important it was for me to get the answers to the big questions. So, I would just say that I really question, just like with Matrix, I question his sincerity. The fact that he won't even consider, if he's saying that's the fakeness, that he won't even consider getting a boat and going out there and see. I mean, I just don't understand. That it just speaks of fakery or just very laziness, or I don't know what it could be, but it sounds like those things. Either just insincerity, laziness, lack of lack of exploration or lack of real depth of truth. You know what I'm saying? I'm willing to risk my life for truth. But that's just me. That's just me.
That's okay.
But cool, man.
Quickly, I'll respond because I know you want to go. And
yeah, about 4 minutes. Go ahead. You could take your last thing.
Yep. Right. For me, like, in this is why I relate to you so much is I have had, not out of body, but I've definitely had some ridiculous experiences in my life that through those, this is just for me, have given me absolutely, well before Flat Earth, no doubt that the spirit realm is real.
Awesome.
And it led me to believe that it is the Bible and Jesus. That's just for me. It's just for me.
Okay.
I could be wrong. And it is because of those experiences that I don't need to drive out there because what happened to me, I know something. You know what I mean? And when I listen to you talk, I hear that same conviction in your voice. Like,
awesome.
A lot of people are going to tell you that you're, crazy or that you're lying or you're making it up. I don't think that. I think 100% everything you're saying is true. You've experienced it. You've been through it. You are not hallucinating. This stuff is real. And yeah, so I look forward to talking to you more.
Sounds good, man.
I got for now.
I appreciate it. So awesome, guys. Thank y'all for listening. And one little tip I'll give you, by the way, maybe it'll mean something to you in the future.
Yes, sir.
In the non-physical realms, when you believe certain things, there's different realms that match that. And what I found is that certain perspectives are contained within the greater non-physical area. So if you have certain experiences that match a certain religion, do you know that there's other people that have certain experiences that match Mohammedanism and discounts yours about Jesus? And other people have experiences about Yahweh. But there's actually another level of experience outside of that. And all of those different, they're like little realms of belief systems that people access. So just consider that, and consider there might be because I'm familiar with the experiences that you talk about. I'm not familiar that those are like a different area. It's almost like let's say you're in a big mansion, but you mistake one room to be the whole mansion. But then you open the door, you realize this is just one room out of many, many rooms. So that's one thing you might want to think about.
I will.
So awesome, guys. I'm going to be back Saturday. I mean, I may do an extra show before then, but definitely I'll be back Saturday at 11:30 a.m. my time about. But again, I'm going to try to make sure it's after Jose's. So but based upon last week around 11:30 a.m. Central Time, and I plan on talking about Spectra. I'm still an amateur at it, but I'm going to spend less time focusing on flat earth stuff and more time actually studying real science. And I'm going to talk about that, and maybe just like I did today, like I focused on the rocketry at first, and then I opened it up to some flat earthers that wanted to join. I'll probably do the same thing Saturday. I'll speak about spectra and electrons and what I'm learning from that, and maybe the last 30 minutes or so, or however, depending on the conversation, or if I'm going to do something else, talk about flat earth afterwards if somebody wants to join. So thank you for joining me. As a matter of fact, are you going to be available Saturday? We could take it up again Saturday if you want.
I will be around Saturday, yes, sir. I wanted to catch you this Sunday, but I had to work and wasn't out in time because I mentioned wanted to talk to you then. But yes, I'll be around Saturday.
No problem. I'll see you Saturday, man. And thanks everybody for joining, guys. Oh, and just real fast on the comments. Let me see if I missed a big comment along the way. I'm gonna respond real fast if I can. I'll just ignore what Fight the Deception is saying. When you want to talk again, we can talk. Stay awake, still awake. Might be in a while. Good point, Gentleys. Awesome. Well, whenever Fight the Deception is willing to talk again, we can talk. But at the moment, I'll consider you a runner, just like Chris Berry. All right, y'all. Y'all be cool. I'll see y'all Saturday.